Alright, so this is going to be a tutorial on common commands in C#. So the most common is console.writeLine. Actually, I thought it was write first. So write is a command, and the command takes arguments. Arguments are what you put inside to tell the command how to operate. So here, the write command, if you mouse over it, it'll tell you the the parameters for it. So the first one is a string. There are 17 overloads. That means there are 17 ways to use this command. But the most common is you just put in a string literal. So basically, you put in some message. Hello world. So that is the most common as the first tutorial on any programming language. So if you run this, it will just close immediately, like so. That can lead into our second command, console.readLine. So readLine, there's only one way to use it. It's used for inputs. So like in the command prompt, when you're typing something and you press enter to tell the program what you typed, that's how you would actually do it. So typically I use this like this only because I want to stop the program from closing, like so. Because it executes this line, and then I guess to here, and it's trying to get the input from the user. So the program has to wait until it presses enter, like so. So if I press enter right here, it closes because it then got the input, right? So another way, though, well, typically the proper way to use this is you would store this into a variable. So let's say we call this variable input, or let's say users input, right? You can put the command here, console.readLine. So the command will get whatever the input is, and then it will store it into this variable, right? And here, this right here, we can then say, let's write out that variable, whatever is stored in that variable. So write whatever value is stored in that variable, which so happens to be what we typed in. So we can run this. We can type in hello world, and then as you can see, you typed it in, right? The first line, it gets stored into that variable, and then the second line of code says write out whatever is stored in that variable, and it was hello world. So if I press enter again, it then goes into the next command. Well, actually, it goes to this command. It waits for the user's input, and when I press enter, it exits the program because that's the last line of code. Now, what you can do is something called string concatenation. So what you can do is you can say plus, and then you can add another string here. We can say what up. We can say like hi, hi buddy. And then it'll first say what you typed in, and as you can see, it added that part. Let me zoom in a little bit. It added that part that we wrote. So when you stitch two strings together, that is called string concatenation. These are terms that you don't really need to know. It's just a functionality that you need to know. So this process is called string concatenation. But what is actually being used is this plus sign. This plus sign is called the operator. There are several operators, and depending on what types you are using, In this case, the two types are a string and a string. So when you add strings together, one gets added to the end of the other. What else? So let's move on to operators and types. So common types are typically the primitives. The primitives are int, integer, string, some text, char, a single character. What else? String, by the way, is not a primitive, but these are common types. We have longs, which is a bigger integer, and I'll get into what that means in a bit. What other common ones are there? String, long, int. Oh, so we got single, which in this case is called float, decimal value. Then we have double, bigger decimal value. So I should move this up here so I can explain them in order. All right, let's put spaces between them. So there are more types. So in numeric values, there's also the decimal, precise value. Okay. So an integer is just a whole number. So this can go from so this is from 2 to the power of negative 31, all the way up to 2 to the power of 31 minus 1. And that is because so that you can represent whole numbers. So this will go up to around negative 2 billion up to around 2 billion. Whoops. All right. So a long is the same way, but it's twice as big. So you can actually go from 2 to the power of negative 63 up to 2 to the power of 63 minus 1. And that's like some really big number, like 9 quintillion or something like that. Let's Google this. Wolfram alpha. We're going to say 2 to the power of 63 minus 1. Quintillion. There we go. So it's 9 quintillion, 223 quadrillion, 373 trillion, 36 billion, 854 million, 775,807. 807. So yeah, so if you need really big numbers, you can use the long. So you might be wondering, if you ever wonder, oh well, I don't need the negative sides, I only need positive integers. Well, that is then going into signing, whether a number is signed or not. So by default, int is what we called a signed integer, meaning that the number itself has a sign to it. So that allows us to go to the negative side, negative or positive integers, hence the signed bit. So what you can do if you don't need the negative side, and like say, okay, I want to allocate the negative portions so that I can go farther positive. You would use the uint, which is an unsigned integer. Unsigned integer. So this goes from 0 up to 2 to the power of 32 minus 1. And this is around 4 billion. So that's 0 to around 4 billion. And that's the same thing that goes for long. So there is a ulong as well. So this is an unsigned ulong. And this goes from 0 up to 2 to the power of 64 to the minus 1. And this is around 18 quintillion, because you're allocating what was previously the negative side and you're adding it to the end, basically. So this goes to quintillion. Alright. So now those are out of the way. A character. So you can write a character in code like this, using these single quotes, and then you can say, the letter T, or you can have the ampersand sign, or you can have the caret sign, or what some people call it the hat. You can do any character or symbol within the UTF-16 specification. So we looked that up. UTF-16 table. So every character in this table, actually goes farther than that. I think it's like page 1 or something. Yeah, so they go by 256 increments. So there are a total of 7,000 something. And as you can see, some characters can't even be displayed in a web page. But yeah, any character you see here can be represented as a character. Alright. And a string is literally just an array or multiple characters, one after the other, which allows us to then write lines of text. So like, remember hello world, and we write those literally, opposed to a single quote. It's a double quote. So characters, you use single quotes. Strings, you use double quotes. All right, now we get back onto numeric values. So a float is a number represented basically in scientific notation, but with base 2. You don't really have to get into the nitty-gritty of what that means. Just have the idea that this allows you to have decimal places. So this can be 1.1, for instance. Although I have to cast it here, because when you write 1.1 in code, it actually means it's interpreted as a double, because these days typically people just use doubles. But I believe you can put an F here, and that would make it so that it's read as a float. So But if you put it, I think it's a D. I think a D is a double. Yeah, yeah. See, double. So, and you want to write in code a float. You would put the decimal value followed by an F. And the difference between these is that the double has twice the accuracy or precision as the float. So let's say I forget at the top of off the top of my head, but let's say the float does, I don't know, 5 decimal places, right? So the double would do twice as much. It would do 10 decimal places, right? Um, but be warned, because with floating point values, again, it's scientific notation, so there is is not super precise. So if you go beyond what a float is capable of, for instance, um, or beyond what a double is can represent, it will round. It will round to the nearest value that it can represent. So you have to be careful with that. Um, or you can, what you can do is go through the decimal value, the data type. The decimal allows you to write decimal uh, numeric values without the rounding errors. Um, I think it goes up to, I think it was 39 decimal places, I think it was. And typically you wouldn't use this unless you were making like simulations that required very precise calculations or stuff. Like, are you like calculating the mass of stars or number of atoms in the universe or something like that? You would use this. But otherwise, you would typically use double. But if you are conscious about um, space, like memory usage, you would then use float. But these days, computers have so much RAM that people just use double all willy nilly. They don't really care. And these guys I've ever explained, they're pretty straightforward. Uh, so now we can go over to operators. So console right line. For an integer, um, let's say int num1 equals 5, int num2 equals, let's say 6. So you can do, you can use the operators depending on the type, and they should behave typically. I mean, most of the time they're intuitive. So let's say num1, you want to add num1 with num2, right? You would just type in num1 plus num2. So this operator first says, okay, there's an integer, and that means I'm going to be expecting an integer on the other side. And sure enough, we do. So if we run this, it'll give us 11. So that's fine. And if we minus, it gives us -1. That's correct. Right? When you get into unsigned and signed, I mean, if you go into unsigned numbers, you then have to be careful. Because, like I said, they can't represent negative numbers. So let's say we have an unsigned integer, right? Num1, 5. And then we're going to minus 6 unsigned from 5. That would be -1 like we just saw. But because um, uh, unsigned integers can't go to negative, you get a very wonky result. See, that does not look -1. What actually happens is, see, as you can see, it's 4 billion something. So what actually happens in the computer, let's say here's the number line 0, right? And all the way over here is like 4 billion, which is the maximum value. Let's say around, because it's not exactly 4 billion, but whatever the maximum value is of unsigned, it will say it was 5. So let's say 5 here, and you wanted to go to 6. So what happens is it will get to 0, and it's like, oh crap, there is no -1 because it doesn't exist. What happens is it wraps around, and then this will be basically 0, and it says, okay, -1 from that. And that's where we landed. So it actually wraps around, and then it gives us that result. So with unsigned, you have to be careful. What you can do, though, is... where is that message? There it is. So what you could do is, if you want to be careful with that, is you can do checks. Actually, no, I won't get into that. For now, just be careful with those if you're going to plan on using those. A character, if I remember correctly, you can add 2 characters together and it will concatenate them. So, oh, my bad. Oh, okay, I forgot. So, characters, even though they are in code representing actual symbols and stuff, behind the scenes, characters are actually a numeric type. So, I could represent these here as well. So this would be a small integer. Yeah. So this will actually be -15 up to wait, no. It would be 0 because I think these are unsigned. C# or car signed. Okay, it seems as if they are unsigned. So yeah, so it goes from 0 up to 2 to the power of 16 minus 1. And you, since you messed with a cheat engine before, this value might actually be familiar. So the maximum value of this is actually 65,535. And that is where that number comes from. So it's 2 to the 16 minus 1. And you can do arithmetic with it as well. But as you can see, it wrapped around, and it gave us actually, why is it 107? Oh, because it's taking the numeric value of that 5 and 6. Okay, I see. So the numeric value of 5. What is 5? Let's check. UTF-8 16 table. The character 5 is 53 plus 54, which is 107. That makes sense. All right, cool. So with character, as you can see, I guess you gotta be careful whether or not you're using it to store individual symbols, or if you're using it as a small integer. So you have to be mindful of that. Typically, you're only going to be using integer. There's rarely times where you would need a really big number, And again, computers these days have so much RAM that people don't even use this anymore. So typically you would just use this. Alright, so that's it for the common types. There are other types too, but we're not going to get into those. And in the future, you're actually going to be able to create your own types if you need. We can go into statements now. So statements are what I guess you would call commands. They are a way to direct code paths, right? The flow of the code, like the direction it goes and everything. So the easiest one I guess would be the if statement, and that is just to tell the computer to make a decision based on a criteria. So let's say we have an integer. Let's say we call it number, and we're going to say it equals 5, right? Oops, stop that running. And let's say we want to check whether or not 5 is smaller than 10. If it's smaller than 10, print on the screen, good job. And if not, say bad job. So an if statement looks like this. So it has the word if, right? And then it has the 2 parentheses where you would put your condition, the criteria, and then it has a body. The body means that if this becomes true, do this. And then an extended version will be an else here as well. So if this is true, do what's inside of here. If it's not, do this instead. All right. So let's say let's check whether or not this number is under 10. So we can say number is less than 10. Right? If this number is less than 10, do this. And we said that it was going to say print onto the screen, good job. So let's write that. Good job. All right. And if it doesn't, we said that it was going to say bad job. All right. And 5 is indeed less than 10, so it's going to say good job. Right. But let's say 15. So 15 is not smaller than 10, so it might say it's going to say bad job now. Just like that. So again, we write the word if, 2 parentheses, and inside the parentheses we write the condition that it's checking for. We have the body, where if it's true, it'll do whatever's inside of the body, and then you can add an else for an alternative route. You can actually extend this even further if you use else if else. Else if. Let's say this turned out to be false, right? So it doesn't do it. It goes else, and then it says it will check another condition, right? You can say if number divided by 2 is less than 10, right? So and then we should else again. So now it's going to say else, check this condition, and if it's true, do this. Otherwise, do this. So we're going to put here, and then we're going to put this here. For this message, we're going to say it's okay. So, oh man, I put that in the wrong place. There we go. So again, we have if, parentheses, condition, we have the body, we have the else, and if you want to check for another condition, if this one failed, you write the word if again, parentheses, then another condition, and at the very end, so you can daisy chain these else ifs as many times as you want, and then at the very end you can have one else. So we're going to say 15 divided by 2, which is 7.5. And if 7.5 is less than 10. If that's true, it will say it's okay. And that's what it should say. And finally, if we put in 30. 30 divided by 2, 30 is not less than 10, so it's going to skip that. 30 divided by 2 is still not less than 10, so skip this. Finally, it's going to say this, which is bad job. Right? Alright. Now, with just if statements, you can make a multitude of programs just using if statements. But it would get really, really repetitive. So things that say you want a loop, in my previous tutorial, we used the for loop. So let's go into loops now, I suppose. So let's touch on the for loop first, because that's what we use in our tutorial. So for a for loop, you get the word for. You have a condition in the parentheses. You have the condition. Then you have the body. Typically, what you would see is something that looks like this. So int, we're counting using an integer. All right, so that's what that's for. We give it a name. I'm gonna call it I. Typically, you will see the word the letter I, as a variable placeholder. You tell it where you want to start. So this is where you tell it wants to start. And then you put a semicolon. After the semicolon, you give it the condition. The condition, let's say, while the I is less than 100. Right? So it's going to check this I. Every single loop is going to, the first thing it's going to do is check the I. And if the I is less than 100, it's going to continue the loop. And then finally, we have the increment part. After the condition, we put a semicolon and then the increment. So I plus plus means that we're going to increment by 1 each time we loop. So let's do console.writeLine. We're going to say, whoops, we're going to write I. So it's going to start from 0, and as long as I is less than 100, it will do whatever is inside of the body. And I guess I should have said this, but the body is defined by these curly brackets. So we have an opening curly brackets and a closing curly bracket, and everything inside in between that is part of the body. And this whole thing right here is called the block of code. So this block, there's a block of code here that has inside of it another block of code and another block of code. All right. So let's run this and see what happens. So here you can see that it started from 0 and it got all the way up to 99. But you might be wondering, well, it says we put 100, but look at the condition. It's I less than 100. All right. So 99 is indeed less than 100, so it printed it. And then it goes up and it increments I again. And this time I is 100. Now look at this condition. If I is 100, is 100 less than 100? No, it's actually equivalent. So it's false. So it doesn't actually print 100. Another operator is less than or equals to. So that means, let's say you want to include 100, right? So less than or equal to. So everything that's less than or equal to 100. So if we run that now, you will see that it actually does print 100 now. I guess now we can do the while loop. So we'll say int I equals 0. So let's say a while loop looks like this. So you write the word while, parentheses, and it has a body. So you can think of a while loop as very similar to an if statement. All right. The while loop checks a condition, and if it's true, it does the body. It's as simple as that. And it will keep doing this body till eternity, until it becomes false. So while I, let's say for instance, is less than 10, right? Do this. So we'll say console dot write line I. So it's just going to keep on printing I until I is no longer less than 10. So we're going to run this, and as you can see, it's going to keep printing zeros because it's just going to go into infinity. The reason why is I is 0, and we haven't actually done anything to I to make it no longer 0. So what we can do is say that every time we print out I, we also want to increment I. Now if we do this, it will stop. And same thing again, the condition, 10 is not less than 10, so that's why it doesn't actually print 10. But the same thing, you can put an equal sign there, and it will indeed print 10. Now, you might be wondering, oh, that looks very familiar from the other two, combined with an if statement. So a for loop is literally an if statement. I mean a while loop. Well, I should say this again. A loop is literally just a if statement that loops back on itself, because just all it does is it keeps checking a variable. And a for loop is literally just a shorthand version of the if statement and a while loop. So a while loop is used, for instance, when there is no numeric value or limit that you know that you have to get to. A for loop is usually used when you know either directly or even indirectly when to stop. A while loop is typically used for other conditions that are not dealing with numeric values. So with those at your disposal, you can make even more programs now. What else can we say? Actually, no, I think that's going to be it for this tutorial.